Today we're going to make a connection between similar figures and scale factors and being able to calculate perimeter. We're also going to be able to calculate area and calculate volume, contingent that the shapes are similar. So the first thing that you want to do is identify a scale factor. And this first page is dealing just with perimeter, because that is more of a level 2 or 3 type of processing. Scale factor, you want to do small is to big. So that's a scale factor. Your small measurement is to your big measurement. And then the second thing that you'll do to use your scale factor to calculate perimeter is create a proportion utilizing it. So this scale factor you made will be the first ratio on your proportion. So let's actually apply these steps. Okay, the actual question, given the first two rectangles, is down here where I started. So given the rectangle with dimensions x and y, and then the larger dimensions 2x and 2y, I want to know if the perimeter of the smaller figure is 34, what is the perimeter of the larger rectangle? So I need to identify my scale factor that relates these two rectangles. So notice that in both cases, my measurements were doubled. So my scale factor, when I deal with the small is to big, is 1 to 2. Again, I have 1x and then I have 2x. I have 1y and then I have 2y. So my scale factor, again, utilizing small is to the big. 1 small is to 2 big ones. So it's double the size. The big one is double the small one. Now I can create a proportion. So if the perimeter of the smaller figure is 34, what is the perimeter of the larger rectangle? So I'm doing small is to big, create a proportion. This goes in the first spot, so 1 small is to 2 big. And then it says perimeter of the smaller goes on top. So I'm looking for the perimeter of the big. And it looks like x equals 68. And that would be whatever that units of measure is. 68 units. Okay, the next one. If the perimeter of the larger rectangle is 63, what is the perimeter of the small rectangle? So I need a scale factor that relates my small, this should be triangle, my small triangle to my big triangle. Let me repeat this. The perimeter of the large triangle is 63. What is the perimeter of the small triangle? So I need to identify the scale factor that relates these two triangles. So here I have 1a is to 3a. 1b is to 3b. So my scale factor is 1 small goes to 3 big. And then I use and apply my scale factor to figure out the missing perimeter. So I want to know what is the perimeter of my smaller rectangle. So we go small is to big, create your proportion, scale factor goes right in that first spot, and then I'm given the larger perimeter. This should be B for big. So that's 63. And then I need to just solve that proportion. 3x equals 63. X is 21 units. So let me just summarize. The first thing I did when I have to calculate perimeter and figure out what the missing dimension would be, you have to figure out the scale factor that relates your two shapes. And then I use that scale factor to create a proportion. It gets a little bit more difficult. And what gets more difficult is when we're dealing with area and volume. This whole page is contingent that all of the dimensions get changed. So if you're increasing all the dimensions, you're going to do something weird to area scale factors and volume scale factors. Area, what you do is square the scale factor. For instance, the reason that I square it is because area is a square unit. Area, let's say I had feet, represents feet squared. Let's say I had centimeters, then area represents centimeters squared. So if I have a scale factor, I need to scale or square the scale factor. So here's an example. If my scale was 1/2, then my area scale would be 1/2 squared, or 1/4. Volume, you will cube the scale factor. The reason I cube it is because volume is a three-dimensional properties. It would be, you have cubic feet, you have cubic centimeters. Volume is always representing three dimensions. So for example, if I had a scale factor of 1/2, then my volume scale factor would be 1/2, take your scale factor, cube it, which is 1/2 times 1/2 times 1/2, or 1/8. You only square or cube it when you're changing all dimensions. And you only square or cube it when you're talking about area, because area is a square unit, or volume, because volume is a three-dimensional unit. Okay, let's apply this. If the side lengths are tripled, then which of the following statements about its area will be true? So I'm going to find my scale factor. It says side lengths are tripled, so my scale factor is 1 to 3. And I know that it's talking about all my side lengths. And area, you can check back up here, is a square dimension, so I need to do a square scale factor. So my area scale is 1 cubed squared, which is 1/3 times 1/3, which is 1/9. And then analyze it. The new area is 27 times the old. Nope. The new is 16 times the old. Nope. The new is 9 times the old. Yes. The new is 3 times the old. No. So it's definitely that third answer choice. Okay, the next one. If the side lengths are tripled, then which of the following statements about its surface area will be true? So I always box off what I'm doing to the side lengths and what I'm looking for. So my scale factor is 1/3, and I'm looking for area, so my area scale, area is a square dimension, so I'm going to square my 1/3, which is 1/9. The new surface area is 20 times the old. Nope. The new surface area is 9 times the old. Yes. And then I just double check. The new surface area is 3 times. Nope. The new surface area is 1/4. No. So that second choice is the right option. Okay, next one. If the side lengths are doubled, then which of the following statements about its area is true? So I have double and area. So my scale factor is 1 to 2 because I doubled it. And I'm talking about area. Area is a square dimension, so I need to square my scale factor, and that would be 1/4. So let's analyze. The ratio of the new area to the old area is 8 to 1. Nope. The ratio of the new to the old, 2 to 1. Nope. The ratio of new to the old, 16 to 1. No. the ratio of the new to the old 4:1. Yes. I identified the correct statement. Okay, the next one, looking at this rectangle, if both dimensions are tripled, then how will the perimeter compare to the old perimeter? So my scale factor, I tripled, so it's 1 to 3. And perimeter is one dimension. We don't square perimeter, and you don't cube perimeter. So I just keep this scale factor since I'm just talking about perimeter. So the new perimeter is 3 times the old perimeter. Okay, so we use scale factors when we change all dimensions, but sometimes you only change one dimension. And you can't utilize scale factors when we're doing the one dimension. What you want to do is find your original, find the new, create your ratio. So looking at this triangle, if the base is doubled, then how will the new area compare to the old area? Notice that I only changed one thing. So I'm going to find my original. So my original area is 4 times 4 divided by 2, 16 over 2, 8. My new area, now I doubled the base, so I'm going to turn that to 8, would be 8 times 4 over 2, 32 over 2, 16. So what happened, I want the new area to the old. So, and they want me to write it as a colon. 16 is to 8, or 2 is to 1. So it looks like I doubled it. Again, I didn't use a scale factor because it didn't change all the dimensions. Looking at this rectangular prism, if the width is tripled, then which one of these statements about its volume will be true? So I'm only changing the width. So I'm going to find the original. Remember, volume, you just multiply all the dimensions, length times width times height. So 10 times 7 times 4, which is 280. My new one, so I'm tripling my width. So this is going to turn to 21. So my new one's going to be 10 times 21 times 4. 10 times 21 times 4 is 840. And then I want to compare them. So I'm going to do original is to the new. So I'm going to do original is to the new. 280 is to 840. See if I can simplify that. The zeros cancel out. 28 is to 84. And 28 does go into 84 3 times. So 1 is to 3. The new volume is half the old volume. The new volume is 3 times the old volume. Yep, because the new is 3. There it is. The new volume is 4 times the old. The new volume is 2 times the old. So definitely the new volume was 3 times the old volume. So just to summarize here, if we are changing all dimensions, that is when you use your scale factor. So your scale factor, and sometimes you square it, and sometimes you cube it, depending on what you're talking about. If you're changing one dimension, you just can analyze how that changing one dimension affects it. So we did original is to the new. Original is to the new when there is one dimension.